try this with your Anytone. Rhinoceros, this is Platypus. I am marsupial at this time, over.
What you just saw was probably one of the most basic tests for durability of a radio suitable for use in life safety applications, and that is taking the radio from a standing position with accessories attached, dropping it on concrete, picking the radio up. The radio should still have the battery connected, should still be on channel, turned on with the accessories still attached, and you'd be able to make a transmission on it as you did before you dropped it on the deck. These new radios take this to a whole new level.
Hello, this is Brett from SurvivalComms.
Today we're looking at the L3 Harris XL400P portable radio. Now this is L3 Harris's NFPA 1802 compliant VHF UHF 7 and 800 megahertz P25 and LTE portable radio. Now, while this is not intended to be an amateur radio and its price tag of around $15,000 would certainly inhibit such, it is currently programmed on 146.52 and some local ham stuff, as well as being a legitimate radio on several local P25 systems. The radio features Bluetooth, Wi-Fi, AES, multi-key encryption, GPS, and all the other features of other high-tier portable radios. We're going to go over many of the features of this radio, but the multitude of ways you can custom configure these modern radios is mind-numbing. I'm not going to waste your time trying to go over every single aspect of this particular radio. Now let's go through the basic specifications of this particular radio before we get started with everything else. And this thing is no lightweight radio. It's 14.7 ounces. It's 6.6 by 2.2 by 1.7 inches. So it's a large radio. And when you look at it compared to our Apex 8000, you can definitely see that it's a much larger form factor. But the body of this radio is scaled up so it will survive the testing as required by NFPA 1802. The radio operates on VHF from 136 to 174 megahertz with an RF power level of a half a watt to 6 watts depending on your programming, and the performance on receive is a 12 dB SINAD at minus 122 decibel milliwatts. The radio also operates on UHF from 378 to 522 megahertz at an RF power of a half a watt to 5 watts of RF power, and its receive performance is 12 dB of SINAD at minus 121 decibel milliwatts. And finally, the radio operates in the 700-800 megahertz band from 763 to 776 megahertz and 793 to 825 and 851 to 870 at an RF power of a half a watt to 3 watts. Its receive performance for a 12 dB SINAD at 700 is minus 121 decibel milliwatts, and at 800 megahertz is minus 120 decibel milliwatts. Now, channel capacity of this particular radio is 1,250 conventional channels and 13,824 talk groups per mission plan. Now, mission plan is just their use of the term, like template would be used for Motorola. It's basically your code plug, and this radio is capable of storing 10 of these code plugs within its own internal memory. And if the radio is allowed to do so through its programming for the end user, you can select one of these 10 different mission plans and load it, and it doesn't take long at all to do that, which actually expands your channel capacity to 12,500 conventional channels and then 138,240 talk groups. Now, this radio does support 2 different digital voice protocols as well as analog FM, and that's Pro Voice and P25. It will not do DMR, and that's a serious shortcoming in the Harris and Motorola product lines, is they don't offer a radio that does P25 analog and DMR, whereas you could go out and buy a Kenwood and it does, and it actually costs you less money. Now the radio does feature 1.5 watts of audio, which is extremely loud. I mean, almost painfully loud for a regular user. In a fire service environment, it would make sense to have that much audio available to you in a portable radio, which is nice.
Moves west-northwestward. By Tuesday, however, strong...
This radio also features a 4,200 milliamp hour battery. Now in my testing, you get 8 hours of battery life out of this radio. There's an awful lot going on inside this radio with the GPS, the Wi-Fi, the Bluetooth, and that causes the battery life to be much less. And depending on how you option up your radio, it could actually increase your battery life to a certain degree, but if you want to maintain the NFPA 1802 specifications of the radio, you're kind of forced to run a lot of these different feature sets within the background, so your battery life suffers. And unlike the Apex series, there's no real way to put an extended capacity battery on this unless they made the radio wider. And this battery is doggone near impossible to get off of this radio. We're not even going to try to pull it off of there. The manufacturer does provide a radio strap with this particular radio. It's a nylon strap made by Homeland 6 of good quality construction, and it's a very good idea that they provided this because this is a very practical way to carry a radio for fire service operations. It places a microphone in a convenient location and allows you to move your radio back and forth. I wore this radio on my belt for a couple days, and it's not a very comfortable radio to belt carry because of the weight and also because of the size of this enormous antenna on here. And the microphone itself, you end up having to loop it around your neck. So I'm glad they provided this option. So what is NFPA 1802? Well, the Cliff's Notes on NFPA 1802 is they're building a radio that's fireman proof, that has multiple safety features, and is probably, any radio that meets that standard is probably an example of the most indestructible portable radios ever assembled. Now from the marketing material that's also in the video description. The radio has been tested for vibration, 3 hours on a 1-inch orbital path at 250 RPM. Impact, a 9.8 foot drop repeated 8 times. Corrosion, a 48-hour salt spray test, followed by 48 hours in a 50% humidity chamber. Display abrasion of 2.2 pounds of load for 200 cycles. High temperature, 500 degrees Fahrenheit for 5 minutes, 203 degrees Fahrenheit for 15 minutes, and then 1,742 degrees Fahrenheit for 10 seconds. The speaker microphone cable is subjected to 35 pounds of pull-out force. Case integrity, 442 pounds of compression load. Temperature stress, -4 degrees Fahrenheit for 4 hours and 160 degrees Fahrenheit for 4 hours. A tumble test of 3 hours in a 46-inch metal drum at 15 RPM for a total of 2,700 rotations. Water submersion, 4 hours at 5 meters of depth. And then the power performance is 8 hour standard duty cycle at max power. So let's talk about the antenna, the elephant in the room, as it were. This thing is enormous. It really is. But part of the standard is to have an efficient antenna, and that the antenna is durable enough to take that tumbling test and also the heat. And I don't know if that's the reason why this antenna is physically so large. I feel like the antenna that Motorola is putting on their NFPA 1802 Apex Next is superior. It's much more flexible than this particular example. And also, I don't particularly like where this connects right here. I feel like I could snap this off myself, and we'll go ahead and remove it from the radio itself, and I'll show you the RF connector here, which has been the same GE connector for a long time now. And you can see the body of it, which is actually robust. I mean, that's steel there. Let's start with the basic manual of arms of this radio. We have on this side of the radio, push to talk switch, 2 user programmable buttons. On the opposite side, we have a universal connector where we hook our speaker mic, programming cable, and other accessories. We have a display on the front and a keypad. We have a display on the top. We have a mode selector knob, and we have a on-off volume control knob here. And the volume control is stepped, which is nice. So it's not like a continuous potentiometer. On this back side of the channel selector knob, we have a 4-position switch right here, A, B, C, and D. And we have a concentric switch located at the base of the volume control knob. We have our antenna, which we've discussed already. We have 2 user programmable buttons on top of the radio as well. On the back side of the radio, we have a belt clip. The belt clip is constructed of metal. It directly ties into the metal chassis at the rear of the radio.
Now we come to the keypad. While Motorola has moved to a touch screen for the Apex Next, Harris is elected to retain a conventional keypad. Now you can see the controls of interest highlighted. To select the menu, hit the 5 key, and you are able to navigate the menu with the 2, 4, 6, and 8 keys. The 3 top buttons under the display are user option buttons, which are completely programmable. The keypad is marketed to be able to be operated with turnout gloves on. Now, while it is possible to do so, it is extremely clumsy, and under no circumstances should any operator be manipulating keypad settings while encapsulated in an ideation environment. The display is a color display, and is a very busy display, perhaps a bit too busy in my opinion, sharing a lot of information regarding activity and active options on the top bar. Some of the icons change color and form depending on what state the radio is in, what network it's on, etc. What you see here is just scratching the surface. Below the top bar we have our mode or channel, and below that we have our zone and radio ID. To the right of those, almost like another layer to the diamond plate wallpaper, we have an activity indicator that you'll see operating when we do our testing. At the bottom of the display, we have the options that are assigned to our soft keys. Again, this is a lot of data to put in a small space, in my opinion.
This radio features voice channel announcement.
Channel 2.
Hazard mode off.
The radio also, with this feature set, cannot be turned off just strictly by turning this knob here. On the front here, you end up having to press this button here to power the radio down. The microphone itself, when attached to this radio, preamps the channel selector knob on top of the radio with this particular feature set.
I really like the microphone this particular radio comes with. This is a very beefy microphone, and speaker microphones take a considerable amount of abuse in the fire service. And you can see here the connection point with the universal connector feels somewhat substantial. You've got this nice beefy mic cord here, and microphone cords with Motorola products are something that's a real Achilles heel. This stuff after a few years just starts falling apart. It interfaces into the body of the microphone. It's a USB-C connector that's protected by this strain relief here. The strain relief is removed by pulling out this screw and then twisting this, and then you can pull the USB-C out. You can replace your mic cord, pop it back in, screw it down, good to go. You got a little light on it, which is nice here. You hold this button down, long key press, you get a light. Hold it down again for a long key press, and it should start flashing. And then you can turn it off just like that. Push to talk on the side. Option button that's programmable here. Channel selector on top here.
Channel 2.
And you can see how this bezel around here, for lack of a better term, changes colors
Hazard mode.
whenever you change channels.
Channel 2. Hazard mode. Channel 1.
And that's really cool because it allows an individual user to look at another user and tell what channel they're on by the color. So if everything's programmed the same and standardized, that right there is actually a really cool feature in my opinion. And then you got your volume up and down, which is a paddle right here. And then on top you got your orange button, of course, for your emergency. And all in all, I think this is a really good item. You can see the illumination around the channel selector knob, and it stays illuminated for a little while after you manipulate the control, so it doesn't stay on all the time. But when you change zones, you can see that it changes colors. Now it doesn't go through a whole full spectrum of colors, but you can see the changes here. Okay, one of the features we're going to talk about here is the man down feature. And a man down feature is basically if the radio is not upright, it's laying on its side, it hasn't moved for a certain period of time, it's going to go ahead and trigger a pre-alert, and it's going to transmit an alert. And this is a demo radio, so it's going to transmit from this radio to this radio, or this one to this one, depending on whichever one has been laying for the longest amount of time. Now, it's going to take us several minutes for this functionality to kick in, so I'm going to go ahead and skip to the alarm going off. And that's our... One thing that's nice about this radio is that it has these easy to manipulate ribs on the outside of the control surfaces, and you're supposed to be able to manipulate all these with turnout gloves. So what we're going to do is we're actually going to do an emergency activation here. I'm going to go into complete darkness with this radio turned off. I'm going to end up having to manipulate the channel, find the right channel to be on, execute an emergency button press, and then make a transmission. And you'll see it all here on this end. Let's get started.
Rhinoceros to Platypus. I am marsupial at this time. Over.
Well, that's a lot harder to do with the gloves on and not looking at the display than you think it is. But what really makes it nice is everything lights up like this and allows you to be able to find the microphone easily. So that's a big win, and I do like that feature set. Like, for example, simple stuff like if your speaker microphone becomes detached, you can see you get an RSM failure indication with an audible indication. And now, if you remove the antenna, you should also get a failure from that as well. Now we've got our radio on top, and you can see that we have a error screen on here saying antenna loss. Another feature that's not unique to this radio individually, but is something that exists in other high-tier portables, is the ability to play back the last received transmission, and we'll demonstrate that.
Rhinoceros, this is Platypus. I am marsupial at this time. Over.
So when doing our testing of this particular radio, I will make note that I do not have an RF adapter for this particular radio, and I do not have a service cable for this particular radio, so we're not going to be able to hook it to service equipment like I normally do. We'll be doing all of our testing over the air using the resources available to me. We will, however, be using some other radios and comparing it to this particular radio. We'll be using a couple of Motorola radios. I have an 8000, I have an Apex 6000, and to test some of the functions of the Harris radio, I've got an XL400 here. And why the heck not? Everybody loves these things for some reason, but we're going to go ahead and throw a Baofeng in the mix too. Let's get started. Let's compare boot up time. Now that's from turning the power on to being able to transmit, and we're not doing it on the system. We're basically just doing it on an analog channel. So, starting now. Now we're going to repeat the test with the Motorola Apex 8000, starting now. Now let's repeat the test with the Baofeng. Why the heck not, right? Going now. One of my biggest gripes about this radio is how much the channel display lags behind the channel position, and I'll go ahead and show you what I'm talking about here. Let's go ahead and do that, and you can see. And now let's go all the way back to position 1, and you can see how much of a lag there is there. Now, and this is in a conventional mode. It's really bad when you're in the trunking mission plan in this particular radio. And we've also noticed that when you move back and forth rapidly, that it actually will place the radio in another zone and it ends up completely lost in the sauce. So I
I'm assuming that's going to be a firmware problem. Now we'll repeat the same test with the Apex 8000. And as you can see, the channel displayed is exactly where the position is without any lag whatsoever. So let's start with a subjective P25 audio quality test. We'll start with our Harris variants right now.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Now we're going to repeat our subjective P25 audio quality test with the Motorola Apex series.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Now we're going to do a subjective analog audio quality test, and we'll start out with the Motorola.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Now repeating our subjective analog audio quality test with the Harris products.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Well, it's Halloween. Get your fangs out. Let's test the Baofengs. Analog FM.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Well, lacking an RF connector for the XL400, we're going to be doing our RF testing using over-the-air means, meaning that we're going to leave an antenna on the device. We're going to do all the tests with the radios at the exact same location, held by myself. This is our first test, which is capturing the transmit signal on my Spectrum analyzer, and you can see the data here. You can see our fundamental, and you don't see any measurable harmonics. And this is the result of the same test with the Apex 8000. And here's the results with our Baofeng. And you can see it's definitely not as spectrally pure as the Motorola or L3 Harris variants, which it wasn't expected to be. And you can see our fundamental and our spikes downrange and the received signal strength thereof. And this is the XL400 on transmit. Here is the Apex 8000. And here is our Baofeng. Okay, let's test for frequency error. This is the XL400. Frequency error for the Apex 8000. Frequency error for the Baofeng. Okay, let's do a receiver test here. Since we're having to do this stuff over the air, it's going to be hard to capture any really good data, but we'll do the best we can with what we have. So we've got our Baofeng is the first up here. We have it tuned to a frequency of 146.52 megahertz, and the squelch is open. And we're going to take a signal generator and we're going to send a signal at 146.5325, which is 12.5 kilohertz away from our frequency, and see if we get a signal. And yes, we do with the Baofeng. Second radio up is going to be our Motorola Apex 8000. And we're generating our signal now, and it's not being received, which is good. And next up is the L3 Harris. Unfortunately, we have to hold the button down because it doesn't latch. You can hear us. We're generating our signal at this time, and it's coming through. So our L3 Harris radio is first up for our next test. We're generating a signal at 146.52 megahertz at a level of minus 85 decibel milliwatts, and you can hear what our signal strength is like on the speaker there. What we're going to do is we're going to generate a signal 12.5 kilohertz away at a level of minus 50 decibel milliwatts, and we're going to see how it affects our received signal here. Now, it shouldn't affect it whatsoever, or if it does, you should barely hear it. Worst case is it's totally going to desense the receiver. Let's find out. Generating our signal now. And you can hear how it's affected our received signal. Second signal off. Next radio is our Motorola Apex 8000. Generating signal now. Second signal off. You can see it had very little influence on the Apex 8000R. And now we're going to perform the same test with the Baofeng. Our second signal is on now. Second signal off. Well, let's talk about our testing results. I am as objective as possible when I do my testing, and I hope that you, as the viewer, appreciates this, even though you may not agree with my conclusions. You know, Motorola versus Harris is like Ford versus Chevy, and there are fans on both sides whom I respect, and I respect both manufacturers. That being said, in 3 decades of government service, I've always used Motorola equipment. Now, as I mentioned earlier, I did not have an RF adapter or service cable for the Harris radio, and being that this is a demo radio, I cannot disassemble or alter such equipment. The tests we performed were over the air without direct connection to the equipment under test. I did each test 3 times to ensure the results were repeatable before recording. All the tests besides the audio quality were done at VHF frequencies to save time, and VHF is spec'd to be the most powerful and sensitive band the equipment under test is capable of operating on. Let's talk about boot up time. This is how long the radio takes to go from off to a ready to operate state in a conventional environment. This may seem inconsequential, but demonstrates the balance between processing power available and the feature set and memory loaded in the radio. The Harris radio took almost 10 seconds to load in this environment, and that, in my opinion, is a long time, and this may indicate that the radio's processing power is lacking. Subjective audio quality testing. Now, this is something for the listener to judge for themselves, in my opinion, but they need to look at it through the lens of speech intelligibility and not high fidelity. Many years ago, when systems went from analog to P25, there was a lot of disdain from users, which myself included, because it sounds canned. Fast forward to today, and going in reverse from P25 to analog, it's evident that digital has improved intelligibility considerably, or perhaps we've just become used to the canned sound. Now, when we did our analog test, the audio in our digital radio still sounds canned, but this is the nature of the audio chain beast. You know, feel free to let me know which you feel sounds better in the comments. Our spectral purity test. Here we measure just how much undesired harmonically related signal is being radiated by our devices under test. Both the Harris and Motorola passed with flying colors. Our Baofeng showed clearly that Christmas has come early, with the tree shown on the spectrum analyzer. No bueno. Now we'll discuss the relative RF power test. Essentially, this is a field strength measurement, and we can see the different results. The Harris antenna, although big and clumsy, is actually a very efficient antenna at VHF, and this has a bearing on the results shown here. The Apex was a close second, radiating only a tad under 1 dB less. The El Cheapo Amazon antenna on the Baofeng isn't doing it any favors. A better antenna does, however, enhance its undesired signal generation and enhances its unique ability to receive undesired RF from the environment. And these are the results from our frequency error test. And yes, the 1980s called and want their frequency counter back. This is a measurement of the difference between the desired program frequency and the frequency that the radio is currently operating on. Typically, the reference frequency is set at the highest frequency the radio is capable of operating on. This frequency counter is only capable of operating up to 512 megahertz, and since it was the most recently calibrated one that I have, it's the most accurate off-air counter I possess, so I decided to stick with the VHF theme. This counter will not resolve at the 1 Hz level, however, on port B, so look at the results shown here as plus minus 5 Hz perhaps. Crystal quality is not what it used to be across the board, and modern equipment should be aligned every 2 years, especially in a P25 simulcast trunking environment. In a conventional P25 analog environment, this measurement isn't as hair-splitting critical, but we have seen as much as 500 Hz of drift between radio PM periods. The results are shown here illustrate what I am talking about. 50 Hz is typically the preset auto-tune window, and any error over 200 Hz causes issue in a P25 simulcast trunking environment. Here are the results of our selectivity test. This is our measurement of how well our devices resist RF 12.5 kHz away from the tuned frequency from entering our receiver when it is in an unsquelched state. The Apex has a very tight receiver, and it is my experience that it takes a considerable amount of RF to climb over that wall, even 10 kHz away. The XL400P has excellent VHF performance and use, and it is unfortunate that its selectivity suffers thus, but that is a trade-off. The Baofeng, of course, will receive this level of signal 30 kHz away, and it is very susceptible to RF interference in use. Here are the results from our adjacent channel rejection test. This is a measurement of a radio signal that opens the squelch of our receiver without any selective signaling on a desired frequency being affected by a higher power signal 1 channel away. You heard those results earlier, and the order of performance echoes our selectivity test results. Now we come to the end of our journey, and there is so much more that could be covered, but I hope you found what we did cover beneficial. Let's go over the pros and cons of this radio, and we'll start with the pros. The rugged construction of the radio is a definite pro. The speaker microphone, its controls, construction, and illumination are awesome in my opinion. The glove-friendly control surfaces work well, and the step volume control is very nice. When you're in a trunking environment, which we didn't really show on here, the RSSI menu allows you to see not just the site you are affiliated with, but those of neighboring sites, as well as sites of neighboring systems that are in your mission plan. Mission plan loading, the ability to make on-the-fly reprogramming, is a great idea for techs and those who may have a requirement to use the radio out of jurisdiction. If this is left in a regular day-to-day user's radio, this should be password protected in my opinion. The loud audio performance was good and not distorted. The VHF performance and testing was superb. I like the fact that the GPS will display MGRS or USNG rather than just Latin long. The one-button Bluetooth on the speaker mic makes pairing to a mask-mounted amplifier easy. And finally, options galore. What we just tested today is just a tiny part of this radio's capabilities. And now this brings us to the cons. The battery life is poor, and the battery attachment is such that swapping a battery is extremely difficult. Harris places small sections of closed-cell foam under the plastic tabs that engage the radio chassis, and perhaps reducing the thickness of that material would assist this. Next, the lag display versus channel position and the zone display when moving across a mission plan is something that needs to be addressed, and this is worse in the trunking environment. And also, changing modes and zones rapidly in a trunking environment causes the radio to randomly select a zone or talk group out of sequence, which is really bizarre, in my opinion, dangerous. Next, the antenna is enormous and makes belt carry difficult. It was smart of them to include a radio strap. The antenna, although a good performer in testing, is inflexible, and the narrow attachment point makes me wonder how it survived the tumble testing. By comparison, Motorola's NFPA 1802 compliant antenna construction is amazing. The radio as provided has an echo reduction feature, and I was unable to see any difference in an analog or digital mode in testing that. And the display, although stylish and informative, is very small. The touchscreen of the Motorola Apex Next has an advantage here, in my opinion. The radio displayed less selectivity in the testing done here than the Motorola. The radio is extremely slow to boot up, as shown in testing. And finally, the radio does not do DMR or next-in. In more rural areas of this state, it is not uncommon to find systems utilizing these modes. This would allow deployed assets like an engine strike team or USAR team or things of that nature, for example, the ability to use their own equipment rather than rely upon cache radios or field deployable infrastructure. Well, I hope you enjoyed this brief glimpse at the XL400P, and unfortunately this radio must return from whence it came. I hope this helps. This is Brett from SurvivalComms. Till next time.